All right, so on number 12, what I would tell you or what I would suggest is to try to separate things out one at a time and worry about your number, then worry about your variables, like worry about m, worry about n, worry about p. Okay? You don't have to physically write out every single one, but if that's what you need to do, that's what I would suggest. So everything is going to come from the fourth column. Like if we have like whatever our fourth roots are, or our perfect fourth powers. So in terms of my fourths, I'm going to have like a to the fourth, and I'm going to have 1. And then 2 to the fourth is going to be 16. 3 to the fourth is going to be 81. 4 to the fourth is going to be 256, if I remember right. And then like 5 to the fourth is going to be 625. So we have 567. So as I go, I want to check to see what number can I factor out from that list of the fourth root of 567. So can I divide it by, I can't divide it by 625 because it's not big enough. Can I divide it by 256 evenly? No. Can I divide it by 81 evenly? Yeah, so if I can divide it by 81 evenly, I'm going to have the fourth root of 81. What is 567 divided by 81? 7. Okay. I can't do anything else with the 7, so the 567 is kind of just out there, and now it's broken up into the fourth root of 81 and the fourth root of 7. So depending on how you want to do this, if you're going to individually look at everything, I'm going to separate it all out to where I have everything that's still underneath the radical, and I'm going to have everything that's not underneath the radical. Everything that's not underneath the radical is going to go together. Everything that's still underneath the radical is going to stay underneath the radical together. So what is the fourth root of 81? 3. So this is just going to be 3, so I'm going to have 3 times the fourth root of 7. Now, I'm going to individually look at each one and kind of go that route. So if I have the fourth root of m to the fourth. So what am I left with? What am I left with? If I have the fourth root of m to the fourth, what am I left with? Just what? What's going to happen to the fourth root and the fourth power? They're going to cancel out, and so the only thing I'm left with here is just m. Do the same thing then with the fourth root of n to the third. So I have 3 n's on the inside. Can I take any, do I have enough to basically bring any n's outside of it? No, so I'm just going to have 3 n's still left inside. Okay? So nothing's going to change. Like everything that I have right there is just going to stay inside. I'm going to have n to the third, and it's still going to be inside the radical. I can't pull a group of 4 out like I could. I could pull out a group of 4 with the m's. The last one then is going to be the fourth root of p to the 11th. So how many groups of 4 can I pull out of, if I have 11 people, how many groups of 4 can I have? 2 groups of 4. So I can have p to the second times the fourth root of p. How many p's do I have left over inside? If I have 2 groups of 4, how many is that? 8. So how many do I have left over? 3. So I have p squared to the 4th root of p to the 3rd. So now all I'm going to do is I'm going to put everything that is on the outside, so the p squared, the m, and the 3, I'm going to put all of those together. So I'm going to have 3m p to the 2nd on the outside. Everything else that I have left over is still going to be in the 4th root. So what do I have left over? Well, I have a 7. I have an n to the 3rd. And I have a p to the 3rd. So everything that's still underneath the radical is still going to stay underneath the radical, and I'm going to have 7, I'm going to have n to the 3rd, and I'm going to have p to the 3rd. And that is my final answer.